We are now looking at target 5.5. This is the last thing we're going to look at before we leave for Thanksgiving break and before our quiz. And our target 5.5 mastery learning objective is I can use the empirical rule to find probabilities of normal distributions. So what the empirical rule states is the empirical rule comes from a truly normal distribution. Not approximately normal, but exactly normal. If a distribution is exactly normal, then 68% of the values are within one standard deviation of the mean. So this center line would be our mean, right? So 68% are within one. So I went one over this way and one over this way. So this little area here is 68%. Okay. Now, when we say, well, this distribution might not be perfectly normal, but we can say it's at least approximately normal, then we just say, well, approximately 68%. So it's a way for us to estimate how many people are going to be within a certain value without actually having to go find out the number of people in that value. Okay. Same thing next, we have 95% are within 2, right? So if I go 1, 2, and 1, 2, it gets me to this line. This whole area is 95% of the people. And last but not least, 99% are within 3, right? So 1, 2, 3, 1, 2, 3. This whole area gets shaded in with 99%. So then 0.5%, right, are on each side. So 1% total is outside of that. And after that, we don't care. It's such a small amount of people that it's unlikely, or it's just, some really small number. So, especially if you got to like 4 standard deviations, 5, it just gets smaller and smaller. Okay. So this 68, right, these numbers on the inside come from, right, well, if 68% are between these two lines, right, I should go back to red. And it's exactly center, then 34 half of it is on this side and half of it is on that side. Okay? Then between our green lines, right, we know 95% falls within there. Well, we've already used up 68. So we have 27% left. And if I cut that in half, I get 13.5. And that's how that falls in there. Oops. And then finally, same thing here. Between these lines, well, I have 99 between these, and between the green, we've already used 95, and we get 4%. And that's, right, if I divide that in 2, that's how we get these two 2%, right? And then finally, we have 1% left, and that's how we have that 0.5% on the other side. Okay? This I'm not so worried about. These percentages will be memorized, okay? You'll just have to know which ones fall within each line. Okay? All right, so example 1. The heights of 1,800 teenagers are normally distributed with a mean of 66 inches and a standard deviation of 2. So we're going to draw a normal curve. When you draw your normal curve, you're going to draw a line on the bottom. That's your axis, like an x-axis or y-axis, but we only have one. And then you have this lovely bell shape. It might take some practice to get a nice bell shape, but that's what we're going to start with. Then we want to put our mean right in the middle. Our mean is 66 inches. Then we go our 1 standard deviation up and 1 standard deviation back. Well, our standard deviation is 2 inches. So if I go up 2, I get 68. And if I go back 2, I get 64. Right? So I'm just adding the standard deviation to get to my next spot. Same thing, I want to do my next standard deviation, right? We do this 3 times. Well, if I add 2 again, I'm at 70. If I subtract 2, I'm at not 70, 62. Okay? So again, I'm just jumping each time by whatever the standard deviation is. And our last one more jump, 72. One more jump is 60. Okay. Then I'm just going to draw nice dotted lines. And then I'm going to fill in my percentages. In the middle 2 is 34. Okay, so the middle is our 34s. The next 2 are 13.5. Percent, the little percent symbols. The next 2 are 2%. And finally, on the outside, we have 0.5%. Okay, so again, those have to be memorized at some point. All right. Then part B asks, what is the probability that a teenager selected at random has a height greater than 68 inches? Okay, greater than 68 inches. Here's our 68 inches. Greater than is going to be this way. So I'm going to take all of these percentages. I have 13.5, 2, and 0.5. I'm just going to add them up. 13.5 plus 2 is 15.5, plus 0.5 is 16%. And that's it. Next one, about how many teens are between 62 and 70 inches. Here's my 62. Here's my 70. Between them, now, not bigger than or less than, right? Between the 2. Well, it's all these 4, right? I'm going to add those up. 13.5 plus 34 plus 34 plus 13.5. The only thing you can recognize is that this is within that 2 standard deviations, and so this is going to equal that 95%. Okay, but you can just also add them. Is it likely that a student is 59 inches tall? Well, 59 inches tall is all the way over here. We say anything outside 2 standard deviations is unlikely, okay? Because it's less than a 95% chance. So no, 59 is more than 2 standard deviations away. From the mean. Okay, so it's either more than 2 standard deviations away or it's less than, and then that would be yes. Okay? All right, let's look at our next example. Example 2. The grade point averages of 1,200 students at East High School are normally distributed with a mean of 2.6 and a standard deviation of 0.6. Draw a normal curve that represents the situation. Again, I have lots of years of practice of drawing bell curves, and mine still don't even look that nice. So if your bell curves aren't super exact, it's okay, but try and practice drawing them nicely, okay, so that they at least look somewhat like a bell curve. It does take practice to draw them. So again, we're going to start with our mean, which was 2.6. On each side, right, we're going to go one standard deviation away, and our standard deviation is 0.6. So 2.6 plus 0.6 is 3.2, or 2.0. One more. Plus 0.6, I get 3.8. Minus 0.6, I get 1.2. Last one, right, we always have to do 3 sets. 3.8 plus 0.6 is 4.4. 1.2 minus 0.6 is 0.6. Okay, so all of these are 0.6 away. Use this pretty blue color. So again, in the middle is our 34%. Over here is 13.5. Then we have our 2's and our 0.5. Technically, these should have percents on them, but it gets a little cramped with that 13.5. Okay. So then, what is the probability that a randomly selected student has an average less than 3.8? So here's 3.8, and I'm going to go less than it. So if I'm adding everything less than it, it's all of these things. And we get, when we add all of those up, we get 97.5%. Okay. About how many students have between a 2.0 and a 3.2? It's just our two 34s. And 34 plus 34 is 68%. Is it likely that a student has a grade point average of 4.0? 4.0 is right here. And again, no. Not likely. It's more than 2 standard deviations away from the mean. All right. Is there more questions? No. That is it. And I actually, before we go, I want to add one thing to this. One other type of question it can ask. So anywhere you have room on your page, right? Something else it might ask, especially when it gives you a number, is, let's say, how many students would you expect to have above a 3.8 GPA? So how many students would you expect to have above a 3.8 GPA? Well, here's my 3.8 GPA. Above that, it's the 2 and the 0.5. So I would expect 2.5%, but that's not how many. How many would then be, well, there's 1,200 students, and I want 2.5%, I'm going to multiply by that probability, right? So that's 0.025, which then equals and 1,200 times 0.025, approximately 30 students. Okay, so sometimes that is another type of question you can see is if you were given the total number of whatever it is, you can multiply that total number by that percentage. Okay. Otherwise, that is it. Have a good rest of your day.